Hello, my name is Sejun Park, and my project is the effect of Han River views on apartment transaction prices in Seoul. So this is Han River in Seoul. The apartment with Han River view is notoriously expensive. So my primary motivation was to estimate this Han River premium using the spatial and architectural features as well as geographical features, like such as distance to river, view angle, obstructions, sound barrier, like floor level, something like that. So yeah, so basically I wanted to predict the apartment price with the 100 review. But the problem is, the 100 review transactions are very rare. In my data set, I managed to have about 3,000 of total apartment trade data, but I only have about 200 trades with the apartment that have 100 review. So I want to investigate if I can correctly predict this apartment price with high review with only like 200 train data. But I also want to investigate um, if there is any way to use the transaction price of apartment without high review in this training process. So in my validation test split, um, the validation and test set only contains the apartment with high review. But in the train set, both the apartment with 100 review or non-100 review apartment can be contained in the train dataset. So basically, like all apartment trade can be contained in train dataset. So let's look at our dataset. So we basically want to predict the price of apartment, uh, which is divided by the floor area. So we want to predict this value using all of the other features like contract date, like apartment floor, floor area, and on that, like every um, geographical features such as the district name, apartment complex, yeah, etc. And as you can see for the validation and test data set, we only have the apartment with 100 review. And for the apartment with 100 review, we have more features. So these features basically like indicating the quality of 100 review. And actually, I manually measure these features and add to the dataset. Uh, so for example, so we have these five additional features that indicate the quality of hand review angle, hand river distance, hand river obscure angle, the existence of noise barrier, and elevated roadway. And I measure this using the satellite image, as you can see in these examples. And also I use the three-dimensional rendering of apartment to measure the angle of Hamlet review. So yeah, so I add 90 different apartment buildings um, for the Hamlet review dataset. And I train machine learning model in a few different ways. So first one is naively train the linear and or the random forest models in the full train dataset. And the second approach is more, I would say, more elegant. So I first, so for each of the apartment complex, I first train the model that can predict the baseline price, which means the price of non-Han River View apartment. And for each of the Han River View trade in such apartment complex, I first predict the baseline price using the first train model, and I train the second model to predict the final price, the final price with the considering Han River view, using this baseline prediction as well as the river view related features. In conclusion, so two-step approach actually improved the validation performance and it is conceptually more appealing. But on the test set, the naive approach with random forest performed the best. Maybe this is because The second approach requires more data for each of the apartment complex. Yep, this is it. Thank you.